All right, hi folks, this is Larry Mussolino. I wanted to record a short video here to help you in the Module 8 MyLabs homework. And I wanted to do a few representative homework problems. One of the things you're going to be doing here in Module 8 is finding approximations to find the area under a curve. And the way we can do this is using a certain number of rectangles. So let's do a few of these examples. So it says the graph is f of x equals 9x squared, and the bounds are going to be the vertical lines x equals 0 to x equals 4. So let's do a lower sum example, and then we can do an upper sum example. All right, so let's do part A, or part 1, I guess they call it. A lower sum using two rectangles of equal width. All right, very important that you draw a diagram so you can get a visual picture of what's going on here. All right, well, the graph of 9x squared, I know that's a parabola that opens up. And so I'm just going to sketch it something like this. So here is the graph of y equal 9x squared. All right, we want to draw the vertical bounds from x equals 0. Here's x equals 0 to x equals 4. So we want to approximate this area under the curve. Now, there's going to be a way to find this exact area under the curve, but right now we just want to approximate it. And so what it says is construct two rectangles of equal width. Well, if I do that, I'm going to mark here x equal 2 to divide this interval in half. Now, what does it mean when it says lower sum? So let me think of it this way. A lower sum means I want to get a lower bound. Now, let me call this, I'm going to create a rectangle here. I'm going to call it rectangle A. Here's rectangle B. Let me look at rectangle B for a second. How am I going to construct a rectangle to represent the area under the curve that I'm labeling as region B? Well, I could either use the left endpoint here to determine the height of the rectangle. So I can construct the rectangle to be this height. This would be my estimate for the area under the curve from x equal 2 to x equal 4. It's not a very good estimate, but that might be one choice. Notice that's an underestimate. Another option might be to use the right edge, the right side of the rectangle. That would make it this area. Well, now that's an overestimate. That would be an upper sum. So what they're asking us to do here in this part of the problem is what's called a lower sum. So the way I'm going to do this is I'm going to create this rectangle using left endpoints. So I'm going to use this red dot here to establish the height of the rectangle. Now let me label the xy coordinates of this. It's x is 2, y is 9 times 2 squared. That's 9 times 4, that's 36. So this point is 2, 36. While I'm at it, let me label this red dot here. 4, x is 4, y is 9x squared. That's 9 times 4 squared. That's 9 times 16, which is, what is 9 times 16? 144, I think. So this point here is 4, 144. All right, now, if I use the left endpoint for rectangle A, this point is 0, 0. So the area, let me make a little table here to help us out. So rectangle A and B. Well, we need the width and the height of each one of these rectangles, and that will give us the area of each rectangle. So I'm going to take the width, I'll multiply it by the height, that'll get us the area. Well, the width for each one of these rectangles is 2. How about the height for rectangle A? Well, it's going to be the left endpoint, the y value of the left endpoint, which is 0. So the height there is 0. 2 times 0 is 0. How about rectangle B? Well, its height is determined by this y value. This y value is 36. So for rectangle B, the width is 2, the height is 36. That's 72. Now I'm just going to add these areas together. 0 plus 72 is 72. So my answer is 72. It's not a very good estimate, because I am missing out on some area. Like, for example, this area, I should be counting. I'm not counting it. So I know my estimate is not that good. All right, let's do an upper sum with 4 rectangles. All right, let me redraw a new diagram here because we're going to need 4 rectangles. Maybe I'll do it over here. So we are drawing this graph, and we're going from x equals 0 to x equals 4. All right, now we're going to draw 4 rectangles. So here are 4 rectangles. So this is going to be x equal 1, x equal 2, x equal 3. All right, but this one says upper sum. Upper sum means I'm going to use the right endpoint to determine the area for each one of these rectangles. So here are my 4 rectangles. Let me call this rectangle A, B, C, D. I didn't draw this graph very well because all these rectangles should have equal width. By the way, the width is 1 for each one of these rectangles. Let me make up a little table. So we're going to have 4 rectangles here that we're creating. I'm labeling them as A, B, C, D. The width of each rectangle is 1. All right, well, all I have to do is find the height of each rectangle. And remember, and once I multiply this together, that'll give me the area of each individual rectangle. Now remember, it said upper sum. That means I really want an overestimate. So I'm going to be using these right endpoints. So let me label. Remember, this graph is y equal 9x squared. So here, this point is 1 comma 9. This point is 2 comma 36. This point is 3 comma, let's work out when x is 3. That's 9 times 9, that's 81. So 381. And this point, I think we worked this out all right. This is 4, 140. All right, we know the height of rectangle A, it's 9. The height of rectangle B is 36. Rectangle C's height is 81. And rectangle D height is 140. Well, I'll just multiply the width times the height to get the area. So it's 9, 36, 81, 144. To get the total area, I'll add these together. And if you add these, I think these work out to be 270. So that's our estimate for the area under this curve. Now, I know it's too much. That's it's an overestimate, right? Because I could see I'm counting this area when I really shouldn't be, because that's not area under the curve. Same with this. These are errors, but I know my answer is just an approximation. All right, so this is the basic setup for some of these examples. Divide the area up into the number of rectangles they specify. Figure out the width of each rectangle. Then you have to decide whether you're going to use the left endpoint or the right endpoint. Some problems might even ask you to use the midpoint as the height. And then once you know the height of each rectangle, I think setting up a little table like this is a good idea. Take the width times the height for each rectangle. Then you can add up all the corresponding areas to get the total area that you're interested in. All right, let's take a look at another example here. This is number 2. And this one says using rectangles, each of whose height is given by the value of the function at the midpoint. So we got to notice that they're specifying the midpoint of the rectangle to determine the height. Estimate the area under the curve using first 2 and then 4 rectangles. And the function here is 5 over x. All right, well, you know, it wouldn't hurt for us to graph this function, get an idea of what it looks like. So if you were to graph 5 over x, I'm going to go to a graphing calculator that I like to use called desmos.com. And let me just graph 5 over x just to get an idea what the shape is. Y equals 5 over x. And so it looks like it's going to be this this decreasing curve here in the first quadrant. So let's go ahead and sketch that out. And it looks like they're asking us to go between 5 and 9. All right, let's come up with a sketch. Let's do part A with 2 rectangles. And so let's graph it. So we know the graph does something like this. And we're going from x equal 5 to x equal 9. And we're dividing it up into two rectangles. And so, so this here in the middle, this is going to be x equals 7. And let's call this rectangle A, rectangle B. All right, well, I know the width. Let's make up a little table here. So rectangle A and B, the width. Well, the width of each rectangle is 2. All right, how about the height? Well, what they're telling me is to use the midpoint to determine the height. So for rectangle A, our rectangle is going to look like this. So I got to figure out what is this y value for the midpoint. Well, the midpoint here would be x equals 6. So this height, this point, let's label this point 6 comma 5 over 6. Remember, the y value is 5 over x. So if x is 6, the y value is going to be 5 over 6. So the height here is 5 over 6. All right, let's go to rectangle B. The midpoint is going to be here. Well, that's at x equal 8. So this blue dot here is 8 comma 5 over 8. So the height is 5 over 8. Let's multiply straight across to get area. Well, let's see. This is going to be 10 over 6. And this is going to be 10 over 8. And it looks like they want us to round this to 3 decimal points. So the total area here is going to be adding the area of rectangle A plus the area of rectangle B. According to our table, this is 10 over 6 plus 10 over 8. Because they want us to go with 3 decimal places, I'm just going to do this directly on my calculator. And if I do that, I'm ending up with 2.917. Okay, so this was an example where they want us to use the midpoint to come up with the estimate. All right, let's do part B. Same idea, but now they want 4 rectangles. So let's do that. Let's do the 4 rectangles. So here's a graph. The curve goes like this. We're going from x equal 5 to x equal 9. And let's break this up into 4 rectangles. 1, 2, 3, 4. All right, I'm going to call it A, B, C, D. And let's see, this would be x equals 6, x equals 7, x equals 8. So for these rectangles, it looks like the width is 1. So we have width equal 1. Well, what we need is the height. Because if we can multiply the width times the height, that'll give us the area of each rectangle. All right, well, let's see. Let's go to rectangle A. We want the midpoint to determine the height of rectangle A here. The midpoint is 5.5. So this red dot is 5.5. Remember, the y value is 5 over x, so it's going to be 5 over 5.5. So the height is 5 over 5.5. All right, what about rectangle B? Well, the midpoint is 6.5. So this point is 6.5, 5 over 6.5. So the height here is 6 over 5.5. And I think you could see that for rectangle C, it's going to be, oops, my mistake here. This should be 5. Whoops, I wrote this wrong. It should be 5 over 6.5. And for rectangle C, it's going to be 5 over 7.5, and rectangle D, 5 over 8.5. Well, I'm just going to multiply these by the width, but the width is all 1. So the area is 5 over 5.5 for rectangle A, 5 over 6.5 rectangle B, 5 over 7.5, and 5 over 8.5. Well, now I'm just going to add these together on my calculator. to get the final answer here. And if you add these together, you should end up with 2.933 when you round to 3 decimal places. Okay, I think creating a table here is a help because it helps you to organize your analysis. And drawing a diagram, I think, is key because then you can visualize the width and height of each rectangle that you're creating here. All right, let's do one more example here. Let me find an example. It's a little different. All right, let's take a look at this example. This is typical of several examples like this, where they're going to give you, instead of giving you the function, like the examples we did a few minutes ago, they're going to give us a table. You could think of it as a table of XY values. All right, so let's take a look here and let's go part A here. It says an upper limit estimate for the amount of material leaked after 4 hours. So we're going to go for 4 hours here. All right, let me plot this just to get a sense of whether this function is increasing or decreasing. I'll explain why that makes a difference in a minute. So when the time is 0, let's plot time here and the leakage here. All right, 0, 30, 160, 2, 150, 3, 240, and 4, 340. 42, 40, 150, and 60. Well, I could definitely see this as an increasing function. Now, keep in mind that if the function is increasing, then the upper limit that we want, the upper estimate, is using right endpoints. But what if the function was decreasing? Then we'd want to use left endpoints for the upper limit. So it makes a difference whether the graph is increasing or decreasing to decide whether you want to use left endpoints or right endpoints for an upper bound. Our graph is increasing, so we're going to use use right endpoints. So this is not our graph, this is our graph, so we use right endpoints. All right, well, for rectangle, let's mark this as A, B, C, D again. A, B, C, D. Here's my table. The width of each is 1. The height is going to be the right endpoints, which they gave me in the table. So it's 3, for rectangle A, it's going to be 60. For rectangle B, it's 150. For rectangle C, it's 240. And for rectangle D, it's 390. So I'll multiply these together to get the areas, add the areas. That will give me the estimate. So you can see I'm just multiplying by 1. So these areas are going to be 60, 150, 240, 340. If you add these together, you should come out with 790 as the answer for that. All right, let's go to part B. Now, part B says lower estimate. Well, for the lower estimate, let me erase some of these. For the lower estimate, I'm going to want to use left endpoints. Let's change over to left endpoints. So for rectangle A, I'm going to use the left endpoint. For rectangle B, left endpoint. So for part B question, it's going to be rectangle A, B, C, D. The width is still 1. But now the height is the left endpoint. So I'm going to use 30 for rectangle A, 60 for rectangle B, 150 for rectangle C, and 240 for rectangle B. And you'll just multiply the width times the height, add those areas together. If you do that, you should end up with 480 here for this part B of the problem. All right. right, folks, hope this is helpful as you are getting started in the Module 8 homework.